Okay, so let's get started here with our scales. So with our scales, it's diagram dot dot actual. Okay, and it's got to be centimeters to centimeters. So we have to be careful with our units. Lucky for us, so nice, right? 8 and 6. So diagram is 8, the actual is 60. Then we have to put this in lowest terms by dividing by 8. And whatever we do to the one side, you have to do to the other side. And so we can get 1 and what's 60 divided by 8? Calculator's out, of course. 7.5. Now that might be the answer, but if you don't see that there, you should try and get rid of your decimal. Okay, so multiply it by 2 and get 2 to 15. Okay, so times it by 2. So you got to be careful with your scales. I may have one or the other. I wouldn't have both. Okay, Vanessa. Because it's not nearly as accurate as 2 to 15. 2 to 15 is exact, where yours is just an approximation. Okay, good question. Okay, so we talked about units, centimeters to centimeters, diagram to actual. So what's the scale factor? Well, we can take 2 to 15, and we convert that to a fraction, 2 over 15, and of course your fraction can go to a decimal. So it would be the top number divided by the bottom number, 0.13 with a repeat bar over the 3 only. Okay, so 0.13 repeating with a 3 repeating. Okay, so scale factor, you're looking for a fraction or a decimal, either or. Okay, next thing we looked at was the maps. So particular distance is 2.5 centimeters. There's your scale, 1 to 600,000. A couple different ways you can do that. First of all, let's convert our scale in the map to 1 centimeter to so many kilometers. Okay, so we have 1 centimeter represents 600,000 centimeters. Okay. So 1 centimeter then represents, how do we convert centimeters to meters? Divide by 100. That crosses off 2 zeros, so we can say 1 centimeter to 6,000 meters. Okay. Then when we convert meters to kilometers, so we divide by 1,000. Okay, so that crosses off the other 3 zeros. So we have our scale, 1 centimeter represents 6 kilometers of actual distance, real world. Okay. So as a fraction, we can go 1 centimeter over 6 kilometers equals, now we measure 2.5 centimeters on the map. Again, it's diagram over actual, so 2.5 must go on the top. And we have to figure out x kilometers. Okay, so we can cross multiply. Okay. 1 times x, or 1x, equals 6 times 2.5. And we get 15 kilometers. Okay. Now we got to really watch our units when we do that. Now what we could do is we could figure out how many centimeters and then convert to kilometers at the end. Okay. But your choice. Typically what you like to do is get your scale into this format, which isn't really correct math-wise, but it works. Any questions? So then for the next part, for similar figures, we looked at whether triangles were similar or not. So the reason could be same angles, or if corresponding sides are in equal ratios. Okay. So we only have to have one of those, and we know the other would be true. That's special for a triangle. So, look at A. Do they have the same angles? Do they? Well, how would you know? You haven't found all 3 yet. Aha, trick. Find all 3 angles. Go. So use your 180 minus rule. Okay. So that's 40 degrees. What's this angle? 110. So 180 minus 40 minus 30. So you just looked at it and you just said, oh, they're not the same, even though you didn't know what they all are. Are these triangles similar? Yeah. So you should say they're similar because they have the same angles. We don't know anything about the sides, but we also don't need to. As soon as we have the same angles for a triangle, boom, we know they're similar. Okay. What about B? Do you know if the angles are the same? Nope. What about the ratios? Should we match up 4 and 9? What do you think? No, we shouldn't match them up. Why shouldn't we match those ones up? Yep.
Because 9 is the middle.
Oh, well done. And 4 is the largest. So you want to match up the size. Okay, so big over big, right? Medium over medium, and then small over small. Okay, because remember we can flip and rotate and turn these triangles. So 12 should be over what? 7 should be over, and what should 9 be over? Okay. So from the other triangle, 12 should be over 4, big over big. 7 is the smallest, so it should be over 2.5. And 9 should be over 3. And so when you divide them, they all give the same ratio. So we can say they are similar because corresponding sides have equal ratios. Okay. Now we're in a different shape. So for a rectangle, or something other than a triangle, you need both reasons. Okay, so you must have both reasons. So, are our angles similar? Sorry, are the angles the same? Yeah, we're good. So we have same angles. What about the ratios? Let's do a check. Find the ratios. Go. Okay, so 2.5, 2.5. So we can say they're similar because same angles and, must use that word, ratios or corresponding sides have the same ratios. Okay, any questions? All right, D. So for D, what we did is we put 3/4 in the middle. They're both equals to 3 over 4. So 3 over 4 equals 17 over y. And 3 over 4 also equals x over 8. And then we solved. So you can do a complete cross multiplication or just do a partial cross multiplication depending on what you have. Solve. Go. So x equals 6. For y, I multiply 4 times 17, divide by 3, and you get 22.6 repeating. So use your repeat bar over top of the 6. Hands up if you got both those answers. Awesome. So this is the basic question. Everything we're doing comes back to this, if you can solve this. The next page, we're going to do these types of things, except we have to be careful how we set them up. Okay, so turn the page over. For this, let's put the small triangle on top, the big triangle on the bottom. Okay, then you can write your 3 fractions. So for the small triangle, let's use y, 10, and 12. Keep in mind here that these angles, they're opposites, they're equal. So I mark that with a dot. That helps me match up the sides. The y is between the angles dot and nothing. So the other side that is between dot and nothing is an 8. So 8 goes underneath. Okay, so you have to be careful. The angles must match up to help match the sides. Okay, so match up the rest. Go. So underneath the 10, we should have a 15, and underneath the 12, we should have x. So we have 2 ratios. Right? One of them is this one, and the other one for the x is those 2 fractions. Okay? Good. Solve. Hands up if you got those answers. Awesome. Okay, so the trick is setting them up. You have to be very careful when you're setting them up. Okay, so we're going to go over that a little more. So with this one, again, mark these angles as being equal because they're opposites. When two lines cross and make the letter X, those angles are equal. So let's put the small one on top and the big one on the bottom. Then we should set up 4 fractions, or 3 fractions, maybe 4. Okay. So for the small one, let's put down y, 3, 8, and 7.2. Okay, fill at the bottom now. Go for it. I'm going to let you try and answer this. There might be some where it's irrelevant and not needed, and that might be what 3 is. Okay, so y matches up with 17. 3 matches up with nothing. Okay, now we're not asked to find it, are we? So let's not worry about that. Okay, so we can just cross that one off. We don't need to worry about that one. Okay. The 8 matches up with the x, which we do need, and the 7.2 matches up with 20. Okay, so this one is the special one because both of these unknowns need that fraction. So we have y over 17 equals 7.2 over 20, and 8 over x equals 7.2 over 20. Okay. Good. Okay, hands up, you got those answers? Awesome. All right, so just be careful how you set them up. Sometimes you're given information you don't need, like the number 3. Okay. For the next one, this is the trickier one. It's helpful for these ones always to draw 2 triangles. Okay. Sometimes you're going to have to add or subtract to find measurements. Right? So you're not going to be given all the numbers you need. For example, on this big triangle, you have 18, but what's the bottom measurement? X plus 6. And the key for here is brackets. Okay. So let's set the large on top, small on the bottom. Do you guys want to do this yourself, or you want me to help you start? Help us? Okay, x plus 6, 18. On the bottom, 3 and 6. Okay. So if I cross multiplied, I get 6 times x plus 6 equals 3 times 18. Okay. Now you didn't really need to cross multiply there, but sometimes you will, so that's why I'm showing it. Okay, so I'm showing a true cross multiplication. Stop. Have I done this right?
No, Mr. Bond.
Yeah, I haven't. Okay. So just something was, my spider sense was ticking. X plus 6 should line up with 6. Okay. And 18 should line up with 3. So I should have those switched up. Okay, so please make those changes. Now when you multiply in here, multiply into both parts, folks. So it's 3x plus 18. $108. $90. So x equals 30. Okay. The key is making sure you have brackets and then use your brackets correctly. Okay.